Hello, AP Chem students. I couldn't find a video that said exactly what I liked, so I made this one, and hopefully I get through it without saying anything I don't mean to say. Up at the top, you can see the equation for Coulomb's law, and that's been in the other videos I've showed, and I don't have a lot more that I want to say about it. In this video, we're going to be focusing more on the energy, and if you're really interested, you can find online how you get the energy from Coulomb's law. But let's just notice that the energy of two charges is equal to this k value, which is a constant that is based off whatever units you're using for your charges. So we have this k value, q1 times q2 divided by d. So you basically multiply the charges together, divide by the distance between them, and that will give you the energy of the system. Okay, so here I have a little system down here. There's q1, there's q2, and there's the distance. So what's the energy of the system? Well, I just need to multiply q1 times q2 and divide by the distance, and I have the energy. Now, what systems like to do is minimize the energy. And I'm not going to get into the details of that, but let's think about what things would make the energy of the system go up and what make the energy of the system go down. Let's start by noticing that q1 is positive and q2 is negative. So when you multiply those together, you're going to get a negative value for E. And that sounds good, like it wants the energy to be as low value as possible, so negative is a good place to be if that's what you're doing. So negative energy is good, and if we move these closer together, D gets smaller, and as D gets smaller, the value of E is going to get more and more negative, and so the system should be happy about that. And so that tells us that opposite charges like to move together, which is something that we already knew. If we move them apart from each other, then this D will grow, and the value will get less and less negative. And now the energy of the system is going up, and that's not going to be as favorable for the system. We could flip one of the charges. What if Q2 was positive? If Q2 was positive, then we'd be multiplying a positive q1 times a positive q2, and that would give us a positive value for E. And so it automatically tells us that the system has more energy than if one positive and one's negative. And in this case, if both of these are positive, moving them apart is something that the system will like, and moving them together is something that the system won't like, because as I move them together, the energy of the system will go up now. So that's the key thing to remember now, is that the energy of electric charges is equal to the product of the charges divided by the distance. Systems will try to make this number as low as possible, as negative as possible. And you can do that by having Q1 and Q2 have opposite signs, by having Q1 and Q2 be as large as possible, and then by having them be as close together. So opposite signs, large values for charges, and close distances will give you the minimum energy that systems love.